Okay, let's get started with 5-4, exponential and logarithmic equations. So there are two very important properties here. The first one is 1-to-1, and that just says that if the base is the same, then x equals y. And if your logarithm has the same base, then x equals y. That's your 1-to-1 property. Excuse me. We also have inverse properties. So if you have log base b of b, those will cancel out, and you're just left with x, whatever that power is. Same thing if this is b to the log base b of x, the b's cancel out, and you're left with x. Okay, so we have some strategies here for solving. So you can get these down, but basically these say that there are two ways to do this. The first is if you get the same base, you get same base as the only term on both sides. So you'll see in this example that we had 2 as a base and 2 as a base. We get to cancel those out. All right. If that doesn't happen, then our strategy is we're going to take a logarithm. All right. So either you got to get the same base or you take a log. Let's see how that works. All right. So the first one is the simple one. The simple one is where we can get the same base. So 3 to the x equals, can we rewrite 81 as 3 to the something? Well, 81 is 3 to the 4th power. So the 3's cancel out, and x equals 4. 5 to the 7 minus x equals 125 is 5 to the 3rd power. The 5's cancel out. 7 minus x equals 3. So we'll subtract 3 from both sides and add x to both sides. And we'll end up with x equals 4. And then on this one, we can say 1/2. A little bit trickier because we have the fraction. 16 is 2 to the 4th power. That's the same as saying 1/2. Since we're flipping the 2 over, and we're bringing a negative power. So 1/2 to the negative 4th. So we can cancel out our 1/2s. 4y equals negative 4. What does y equal? Y equals negative 1. All right, your turn. See if you can do it. 8 is 2 to the 3rd power. So x minus 1 equals 3, and x equals 4. 1/3 to the y equals, to the y equals 3 to the 3rd power. That's the same as 1/3 to the negative 3rd power. So the 1/3s are going to cancel, and y will be negative 3. Okay, so what happens if we can't just get the same base on both sides? Because there's no way to write 16 as 5 to the something. Then we're going to rewrite as a logarithm. So we can rewrite this as log with our base. Base 5 of 16 equals 3x. And let's solve from here. So divide by 3 and divide by 3. So we'll get log base 5 of 16 all over 3 equals x. That is our exact answer. And then it does want us to solve this to 4 decimal places. So let's go grab our graphing calculator. Let's see, where are we? There we go. So this was log base 5 of 16. Remember, we write this as log 16 divided by log 5. And 1.7. So just as a check right there, 5 squared is 25. So 16 should be a little bit less than 2. So the number does make sense. And then remember, we were dividing this whole thing by 3. So 0.5742 is approximately equal to x. Let's do the next one. This is log base 4 of 71 equals 3x plus 2 when we write it. So we'll have log base 4 of 71 minus 2. So if you want to, put the whole log in a parentheses so you don't get it mixed up. And then the whole thing divided by 3. That's equal to x. All right, plug this in and get an approximate answer. Log base 4 of 71. We're going to say log 71 divided by log 4 and minus 2. So we can answer, let's subtract 2. And then we needed to divide by 3. So 0.3583. We have 3583. It's approximately equal to x. All right, your turn. Give it a shot. All right, so hopefully we said log base 10, or just log of 7 equals 2x minus 3. And so we'll say log of 7 plus 3. Put that in parentheses if we want to. All divided by 2 is x. That's our exact answer. We'll plug it in to the graphing calculator. On this one, we can go straight to log 7 because we have the correct base. Plus 3. Make sure we hit enter before we divide by 2 so we get our order of operations correct. 1.9225. Approximately equal to x. Okay, so what about if we have a more complicated power here, an x squared? Same deal. Let's go ahead and divide both sides by 4 first. We'll have e to the x squared equals 64 divided by 4 is 16. And let's go ahead and rewrite this. This is log base e, otherwise known as the natural log of 16 equals x squared. So how do we get x by itself? We're going to square root this. So the square root of the natural log of 16. And since we're the ones doing the square rooting, we've got to put a plus or minus in here. So that equals x. Let's go find the exact answer. So the natural log of 16. And square root it, so to the 0.5 to the 1/2 power. So we'll get plus or minus 1.6651. It's approximately equal to x. Your turn. Hopefully we said y squared is equal to log base 5 of 27. So we'll say y is equal to plus or minus the square root of log base 5 of 27. And let's go to the calculator for an approximate answer. So we'll say log 27 divided by log 5. And we get an answer, and then we'll raise that answer to the 0.5. So plus or minus 1.4310. Approximately equal to x. Excuse me, y in this problem. All right, so that's how to solve exponential problems. Let's go ahead and solve our logarithm problems. So it's just going to go in reverse. So in this case, if we can get a single term and we have the same log base on both sides, they're going to cancel. Those are the simple ones. The harder ones, if we can, we're going to get all the logs on one side, and then we'll rewrite it as an exponent. So let's see this first one. So the left side, there's nothing to be done. The right side, we need to get a single log over here. We can combine these using the properties of logarithm. It's going to be x times minus 2. The logs get to cancel. We have 2x minus 3 equals x squared minus 2x. An x squared problem, so we need 0 on one side, x squared, and then those are going to cancel out. No, they're not going to cancel out. Sorry, that's a minus. So minus 4x, and then plus 3. And that does factor into x minus 3 and x minus 1. So x equals 3 or 1. Your turn. Natural log of x plus 8 equals natural log of x times x plus 3. We have a single term and the base is the same. Cancel your logs. X plus 8 equals x squared plus 3x. Subtract your x and your 8. We'll get 0 equals x squared plus 2x minus 8. So that factors into x minus 2 and x plus 4. So x equals 2 or negative 4. Okay. All right, now the one thing here is that the parentheses cannot be 0 or below. The parentheses cannot be 0 or below. So on this case, negative 4 doesn't work because it would make this parentheses less than 0. Okay, you cannot do logs of 0 or negative. Okay, so important. So on this one, everything else works with a 2. 2 plus 8 is positive, 2 is positive, and 2 plus 3 would be positive. So x equals 2. All right, let's try it again when we don't have logs on one side. So let's put these together. Log base 3 of, this would be 9x over x minus 8 equals 4. Let's go ahead and rewrite this. This is 3, that's your base. Power is 4, 3 to the 4th equals 9x over x minus 8. 3 to the 4th is 81. So we're going to have 81, let's times both sides by the x minus 8. Get 9x. So we'll have 81x minus 81 times 8. What do we got here? 648, is that right? 648, there we go. Equals 9x. And so if we subtract this, we'll get 72x equals 648. What is 648 divided by 72? 9. So x equals 9. And we got to go back and check. If we plug in 9, will that be positive? Yes. If we plug in 9, will that be positive? Yes. X equals 9 is our solution. Your turn. So we'll have log base 2 of 4x over 2 equals 2. So 2 to the second power equals 4x. 4 equals 4x over 2. 8 equals 4x. X equals 2. That works for both of these. So that is our answer. All right, let's just check one with no solution and we'll be done here. So log base e, a natural log of 3 minus x squared equals 7. So let's go ahead and say e to the 7th equals 3 minus x squared. And so we'll have e to the 7th minus 3 equals negative x squared. And let's divide by negative 1. So this would turn into 3 minus e to the 7th equals x squared. 3 minus e to the 7th is a negative number. You cannot square root a negative. We're going to have no real solution. So we get an imaginary solution. Not what we're looking for here. All right, that will do it. We will see you in class.